Hi, in this video, we're going to talk about Ethernet, the dominant wired LAN technology. Bob Metcalfe and David Boggs are credited with the invention of Ethernet in 1973 while working at the Xerox PARC in Palo Alto. They built upon the work done with the Aloha protocols. The first implementation of Ethernet used a 3/8-inch yellow coaxial cable. This cable was very stiff, very hard to install. The cable was given several nicknames. Frozen yellow garden hose and frozen yellow snake were the most common. The network devices were attached to the coax cable with a so-called vampire tap, which pierced the cable and made the connection to the inner wire that carried the signal. This tap had to be placed at precisely 2.3-meter intervals. The first Ethernet standard limited the length of the cable to 500 meters and the data rate to 2.94 megabits per second. There was a lot of competition for LAN technology in the 1980s. IBM's Token Ring and ArcNet were the chief competitors. But Ethernet won out chiefly because it adapted better and quicker in the data rate and costs than the competition. The physical topology of Ethernet has evolved considerably over time. For the coaxial cable installations, the network devices were attached in a bus configuration. All the transmitted frames traveled to and were processed by all the adapters connected to the bus. So broadcasts were heard by every adapter on the LAN. And all network transmissions were susceptible to collisions. For this topology, we say that all the network devices are in the same broadcast domain and the same collision domain. The migration of Ethernet from coaxial cable to twisted pair cable facilitated simpler and cheaper installations. Instead of the bus topology, the Ethernet adapter could be connected in a star topology. In this configuration, all the devices in the LAN can be connected to a passive hub. The hub is just a repeater with multiple ports. A repeater just receives the bits of the message on a port from a network device, cleans the bits up, and sends these same bits out all other ports. So in this type of star topology, all devices on the LAN are still in the same collision to broadcast domain. In the mid-1990s, the Ethernet switch was developed. In the star topology, an active switch replaced the hub. This active switch creates isolated mini-LANs, each running a separate Ethernet protocol. The Ethernet switch bridges each of these mini-LANs, so it is a multi-port bridge. The benefit of this topology implementation is that there are no collisions. However, note that all the devices attached to the switch can still receive all broadcasts. The Ethernet frame encapsulates the higher layer of protocols. Let's examine the details of the Ethernet frame. The first 8 bytes at the beginning of the frame form the preamble. The preamble indicates to the receiving network adapter that a frame is coming. This allows the receiver to lock on to with the data stream before the actual frame begins. Thus, the sender and receiver clock rates are synchronized. The first 7 bytes of the preamble start with a distinct pattern, alternating ones and zeros. The final byte is a different pattern, which tells the adapter software that the link layer data follows. The 6-byte source and destination addresses follow the preamble. If the network adapter receives a frame with a destination Ethernet address which matches its own address, or with the broadcast address, the adapter passes the data in the frame to the network layer. Otherwise, the adapter dumps the frame. The type field indicates the layer 3 protocol, which is typically IP. The middle section of the frame consists of payload data, including any headers to the other protocols. For example, TCP or IP. The frame ends with a 32-bit trailer, which is the cyclical redundancy check used to detect corruption of the data in transit. Ethernet is connectionless and unreliable. There is no handshaking and no acknowledgements between the sending and receiving network adapters. Any reliability must be provided by higher layers. In section 6.3, we discuss media access control for communication over a shared medium. Ethernet SMAC protocol is an unslotted carrier-sense multiple access collision detection with binary backoff. As described before, Ethernet won the link layer battle because it was adaptable. There are many different Ethernet standards that define both the link and physical layers. All the standards share a common MAC protocol and frame format, but they can differ over a wide range of data rates and work over copper and fiber cables.